Agriculture Institute of Engineering and Technology. Today we will discuss few more topics of Fourier series. So let's begin with first topic, that is half-range cosine series in the interval 0 to pi. As you can see, previously we had studied interval 0 to 2 pi. Now its range is half, so its range is 0 to pi. And now here we are specific studying cosine series. Okay, so the formula for Fourier cosine series is given by f of x is equals to a0 by 2 plus summation n from 1 to infinite an cosine x. And the value of a0 is 2 upon pi integration 0 to pi fx dx, and an is equals to 2 upon pi integration 0 to pi fx cosine x. Okay, so whenever half range cosine series is asked, then you have to apply this formula for the interval 0 to pi. Next, let's see half range sine series in the interval 0 to pi. Okay, so the formula is f of x is equals to summation n from 1 to infinite vn sin n x, and the value of bn is equals to 2 upon pi integration 0 to pi fx sin n x dx. Okay, so let's see one example, that is find the half range sine series of function fx is equals to pi minus x in the interval 0 to pi. Okay, so the question is we have to find sine series, so we have to find bn. Okay, so the formula for bn is what? 2 upon pi integration 0 to pi fx sin nx dx. Okay, so the function fx is what given in the question, that is pi minus x. Okay, and sin nx dx. Now to solve this integration, we have to apply this uv rule formula, right? That is uv1 minus u dash v2 plus and so on. Okay, so here our u is this and sin nx is v. Okay, so just apply this formula. So here you have 2 upon pi u as it is, so pi minus x as it is, integration of sin nx, that is minus cos nx upon n. Okay, minus, now the derivative of this term. So derivative of this term is minus 1, so here we will write minus 1. Next we have to integrate this term. So here minus as it is, and integration of cos nx is sin nx upon n square. Okay, and the limit is what? 0 to pi. Right, now just apply the limit. So here 2 upon pi as it is. When you will substitute pi here, so pi minus pi is 0, so this term gets cancelled. Sin and pi, we know the value of sin and pi is 0, so this term is also 0, so upper limit is 0. Okay, minus, now substitute lower limit. So when you will substitute 0 here, so here we have pi. Okay, and here we have minus cos 0 upon n. Okay, and this sin 0 is 0, so we have only this term. Just simplify it. Cos 0 is 1, minus minus will become plus, pi will get cancelled. So the answer of bn is what? 2 upon n. Okay, now we know fx formula. Fx is what? Summation n from 1 to infinite vn sin nx. Okay, so just substitute the value of bn. What is the answer of bn? Bn is 2 upon n, right? So just 2 upon n sin nx. So this is the Fourier series formula of the function pi minus x. Let's see one more example. Find the half-range Fourier cosine series of function fx is equal to sin x in the interval 0 to pi. Okay, so here we have to find cosine series. So we will find a0 and an. The formula to find a0 is 2 upon pi integration 0 to pi fx dx. Function fx is sin x, so just substitute and integrate sin x. So here you will get 2 upon pi minus cos x, limit is 0 to pi. Apply the limit, so you will get 2 upon pi minus cos pi plus cos 0. Okay, now we know the value of cos pi, that is minus 1, so it will become plus 1, and cos 0 is again 1, right? So final answer is 4 upon pi. So the answer of a0 is 4 upon pi. Now let's find an. So the formula to find an is 2 upon pi integration 0 to pi fx cos nx dx. Okay, So just substitute the value of function, that is sin x. Now to solve this, bring this to inside. So here you will get next term as 1 upon pi integration 0 to pi 2 sin x cos x. Now to solve this integration, firstly we have to apply the formula of 2sc, that is s plus s. Okay, so just apply this formula 1 upon pi as it is. Sine plus sine. So first term here we will add them. Okay, so here we have 1 plus n into x, plus here we have sine 1 minus n into x. You have to add this x plus nx, and x is taken common in both the term. Now we will integrate it. Now we know the integration of sine is minus cos. Okay, so here we have minus cos 1 plus n into x upon 1 plus n. And again integration of sine is minus cos. So here we have minus cos 1 minus n into x upon 1 minus n. And the limit is 0 to pi. So apply the limit. So you will get 1 up and I have taken minus common. So here we have minus 1 upon pi. And in place of everywhere, firstly I have written here pi and minus your lower limit. So here we have this term. Okay, so now we have to simplify this term, that is cos 1 plus n into x. So just multiply pi inside. So here you will have cos pi plus n pi. Now pi plus n pi. So consider this n pi as a theta. So we have cos pi plus theta. So pi plus means third quadrant, right? So in third quadrant, the cos is what? So here you will get answer as minus cos theta, and theta is n pi. So here we have minus cos n pi. Now we know the value of cos n pi, that is minus 1 raised to n. So here we have minus 1 raised to n. Okay. Next, we'll solve this, that is cos 1 minus n into pi. Multiply pi, so here you will get cos pi minus n pi. Now pi minus n pi, that means second quadrant, so you will get minus cos n pi, because in second quadrant cos is negative, right? So again, value of cos n pi, that is minus 1 raised to n. So here we have minus 1 raised to n. And we know the value of cos 0 is 1. So just substitute all the values. So you will get an as minus 1 upon pi. Here in place of cos 1 plus n into pi, we have minus 1 raised to n upon 1 plus n. And again here we have minus 1 raised to n upon 1 minus n. And in place of cos 0 we have 1. Just we have to simplify this term to get the answer of an as 2 upon pi minus 1 raised to n plus 1 upon 1 minus n square. Okay, you have to the calcium, so here you will get 1 minus n square. Okay, now here it is specific written that for n greater than 1. Why? Because if you will substitute n is equals to 1 here, the denominator will be 0, so it will become undefined, right? So we will solve for n is equal to 1 separately. So we will solve a1. So the formula is 2 upon pi integration 0 to pi fx cos nx, but n is 1, so here we have cos x dx. Okay, the value of function fx is sin x. Just take 2 inside, so here we have 2 sin x cos x. Now we know it is sin 2x integrated, so you will get 1 upon pi into minus cos 2x upon 2, and the limit is 0 to pi. Apply the limit. Now we know the value of cos 2 pi is what? 1, and cos 0 is 1, so it will get cancelled, and the answer of even will be equal to 0. Okay, now finally write down the final answer. So Fourier series of function fx is given by the formula a0 by 2 plus summation n from 1 to infinite en cos nx. Bn is 0 when we are finding the cosine series, this term will not come. Okay, so just we have to substitute the value of a0 and an. Okay, so just substitute the value, so you will get this answer. Here I have written summation n from 2 to infinite. Why? Because the a1 is 0, so summation will come from 2 to infinite. Okay, now just simplify it further. Substitute n is equals to 2, 3 and so on, so you will get this term. And I have taken 2 upon pi common, so here you will get 1 minus 2 upon 3 cos 2x minus 2 upon 15 cos 4x and so on. So this is the Fourier series of a function sin x. Now let's move to the next topic, that is half range cosine series in the interval 0 to l. Okay, now the interval is in the form of 0 to l. So the formula is f of x is equal to a0 by 2 plus summation n from 1 to infinite an cos n pi x upon l. Just minor changes when we have l. Okay, so whenever you have L, you have to write in this form, that is n pi x upon L. Now the formula to find A0 is what? 2 upon L integration 0 to L fx dx, and the formula to find An is what? 2 upon L integration 0 to L fx cos n pi x upon L dx, right? Now the half-range sine series in the interval 0 to L is given by the formula f of x is equals to summation n from 1 to infinite Vn sine n pi x upon L, and the formula to find Vn is 2 upon L integration 0 to L fx sine n pi x upon L dx. Okay, so whenever you are asked to find cosine series in the interval 0 to L, you have to apply the previous formula, and for the sine series you have to apply this formula. Okay, let's see one example. The question is, find half-range sine series of e raised to x in the interval 0 to L. Now, if in the question the interval is given in the form of L only, so we will take L throughout. Okay, and we have to find sine series, so we will find Bn. So the formula is what? 2 upon L integration 0 to L fx sine n pi x upon L dx. Okay, just substitute the value of function fx, that is e raised to x. So here you will get 2 upon L integration 0 to L e raised to x sine n pi x upon L dx. Now to solve this, here we will apply the formula e raised to ax sine bx dx. So the formula is what? E raised to ax upon a square plus b square, a sine bx minus b cos bx. Now we know, you just compare this. So your a is what? Here 1, and b is what? N pi upon L, right? So in this formula, everywhere in place of a you have to write 1, and in place of b you have to write n pi upon L. Okay, so just substitute in that formula, so you will get this term. Okay, now we will apply the limit. So here L square multiply with 1, so here you will get L square plus n square pi square. This L square will go in the numerator and 1 L will get cancelled. So here you have 2L. Okay, firstly apply limit, upper limit here. So here you will have e raised to L into, now we know here you will substitute L, so L will get cancelled. So sine n pi, the answer of sine n pi is 0. So this term is gone, and substitute here L. So here you will have cos n pi L upon L. L will get cancelled. So here we have only cos n pi, and this minus n pi upon L as it is. Okay, minus. Now apply lower limit. So here you have e raised to 0, and this again sine 0 is 0. So this term is gone. Minus n pi upon L as it is, and here we have cos 0. Now we have to apply the formula of these two terms. So we know cos n pi is what? Minus 1 raised to n, and cos 0 is 1. Okay, again this n pi upon L is taken common, and we have just simplified it. Okay, so this is the answer of Bn. Now we have to substitute this answer in the fx formula. So fx formula is what? Summation n from 1 to infinite Vn sine nx. Okay, so just substitute the value of Vn here, right? So you will get the Fourier series of function e raised to x in the interval 0 to n. So in today's session, what we had studied half-range cosine series and sine series. Okay, half-range sine. So whenever cosine series is asked, so you have to find a0 and an, and bn no need to find. Okay, and the formula for fx will be what? A0 by 2 for the interval. Suppose we are taking the interval 0 to pi. So the formula will become a0 by 2 plus summation n from 1 to infinite an cos nx. Okay, and when we are asked to find the half-range sine series in the interval 0 to pi, you have to find bn, and the fx will be summation n from 1 to infinite bn sin nx. Okay, and if it is asked in the interval 0 to L, we have to find same thing, that is 0 to n, but everywhere in place of pi in the limit we are writing L, and here we have to write cos n pi x upon L, and here also we have to write sin n pi x upon L. Okay, I hope you have understood. Thank you for watching.